Hi everyone, in this video I'm going to be talking about what we've learned about inverse tables and inverse graphs. So in this first question we're being given a table for the original function, which is called f of x, and we need to fill in the table for the inverse of f of x. So first I just want to talk about what we know about what an inverse function does. So we've learned that when we have an original function and we want to write the inverse function, we have to do the opposite operations from the original steps, and we have to do them in the reverse order. When we do the opposite and reverse steps, the inverse function undoes the original function. So I'm going to make a little flow chart just for the first set of values, and this will look familiar from the flowcharts we've seen in class, but this will help us better understand what we need to do in the table. So for this first row, -1 is my x value, so we'll call that our input. So -1 is our input, and we're putting it in to the we're putting it into the original function, which is called f of x. So I'm taking -1, I'm putting it into my original function, so that arrow represents us putting it into the original function f of x. And then as you can see from my table, the number we get out is 6. Now, let's think about what would happen if we took 6 and made it the input for our inverse function. So now I'm taking 6 and I'm putting it into my inverse function. And because the inverse function is undoing the steps from the original function, it should give me back my original input from the beginning, which is -1. So once again, to explain that one more time, the original function is doing some steps. We don't even know what the function is. It doesn't really matter. It's doing some steps, some original steps to -1, and it's getting out 6 as the output. So if I take 6 and put it through my inverse function, which does the opposite and reverse steps to undo those original steps, it's going to give me back my original input. So that means my output for the inverse is that original input, which is -1. So I don't need to make a flowchart for every single row, but this is showing us that whenever we have our original function table, our inverse function table is going to have the same values, but they're just going to be switched. The inputs and the outputs switch. So for my next row, which has 0 as the input and 4 as the output in my original table, then for my inverse table, 4 is the input and 0 is the output. So I just switched them. For the next row, 1 is the input and 3 is the output. So when I switch them, 3 becomes the input and 1 is the output. For my next row, I switch 2 and -7. So my new input is -7 and my output is 2. Make sure you don't change any of the positive or negative signs. We don't need to change anything from negative to positive or positive to negative. We're just switching the placement of the values in the table. The inputs and outputs just switch. None of the actual values themselves change. So in the last row, 3 and -10 switch to give me -10 as the input and 3 as the output. So now we know whenever we have an original function table, we can just switch the inputs and outputs to get our inverse table. Now we're going to take a look at graphing an inverse function when we're given an original function. So it says, given the graph of the original function, which is purple below, use symmetry to sketch the graph of the inverse function. So I'm going to go ahead and zoom in on this graph. And this is my original function in purple. Now, what we learned in class is that because the inverse function, switches our input and output values, we end up reflecting our original function gets reflected over the line y equals x to give us our inverse function. And just to make sure you understand, y equals x is just a line with a slope of 1 and a line with a slope of 1 and a y-intercept of 0. So it goes through the origin there, and it has a slope of 1. So that's our diagonal line, and that is the line that our original function needs to be reflected over in order to sketch our inverse function. Another way we can think about this is kind of thinking back to the table. For example, I think sometimes if you have a grid, it's helpful to look at one specific point on the original function and start just by reflecting that one point to kind of help us. So this point, we can write down the coordinate point is 1, 2, 3, 4, -5, 4. So remember, in my last problem, we talked about how the inputs and outputs switch for the inverse function. So that means on my inverse, I just switch -5 and 4. So I should have the point 4, -5 on my inverse. So this is just going to give me a place to start. So I can always put the point 4, -5 on my inverse to get me started. So I'll go ahead and find that point. It's down here. So I know that's one point in my inverse. Now, of course, it would be taking way too long if we did that for every point, but it just gives us an idea of how switching the inputs and outputs causes us to reflect over the line y equals x. You can kind of see how these points are mirrored across the line y equals x. Now I just need to kind of draw the rest of my function. So the way I do this is I kind of turn my head so I'm kind of looking at that diagonal line as my centered point or my center of the picture, and I'm trying to create a mirror image. So I can see, for one thing, it's helpful to look at where also it crosses, because I know that where my original graph crosses the y equals x line, my inverse is also going to cross there. So it would be helpful if I just drew at least up to here, so I can see I'm creating this like triangle kind of this mirrored picture, and I know it's going to I know they're going to intersect. If they intersect on the line y equals x, they intersect at the same spot on y equals x, and then I just kind of can extend it, and I see that it does mirror. You know, it doesn't have to be perfect, but I can see how this red part of the line on the other side is reflecting the purple part of the line on the other side of the diagonal. So that gives me part of my graph. So I'm just going to kind of go over that again. That's like half of my graph, and then I kind of have to have this little bend in my graph, which I can think it's going to go away kind of like this. And again, it's probably not perfect, but it's going to go away like that. And then, so my last part needs to, I'm still trying to create this mirror image, so it needs to go like this. And that's like close. You can also like kind of check yourself by finding other points if you want, but like I said, like I'm sure I didn't do it perfectly, but you can tell that I have pretty much created that mirror image over the line y equals x. Okay, so that might take some practice on paper, but that's how you draw your inverse graph when you're given your original function graph.